Hi and welcome. We are at OK Corral, it's high noon, and today we will have a screwdriver showdown. On a more serious note, in this video I will explain by the end of the video why for me at least these two screwdriver set of these two screwdrivers is the best in the world. But throughout the whole video I will explain some basics about screwdrivers in order to share my knowledge and experience that I've acquired over the past decades, hoping that it will help you when you are working or when you are shopping for screwdrivers, and also hoping to get some more corrections and additions as I have received from Mr. Gavin McRae. I hope I haven't mispronounced your name. So he recommended that I try this screwdriver, and I want to thank him because it really is very good, and it's become my go-to screwdriver, at least for wrenching bicycles. So thank you very much, sir. And now let us begin with the video. As usually I will put chapters or table of contents in this video that you can use to see the topics and skip to the parts of interest, and I wrote them down here. Among other things, because I'm one of the most absent-minded persons I know, so in order to not make the video last for hours but to not miss any important stuff, here I made the table of contents. So the first thing that I will talk about today are the types of screwdrivers. Here we have some, how to say, ordinary screwdrivers that have a handle and a blade and a tip. There are dozens of various tip types. This one has like a 5.5mm hex tip, and this is, I think, Phillips, no, POZIDRIV one, sorry. So there are different types of tips, but that's a topic for another video. I will skip that part. Here we will just concentrate on the drivers themselves. So these are like ordinary screwdrivers. We have that kind of screwdrivers. We also have these rather small, this is called a precision screwdriver, and they usually have a cap that rotates. This one is very poor quality, so the cap stays stuck when I'm turning this, but generally it's for fine tuning and for low torque use, for precision stuff like servicing iPhones and laptops and so on. So that's another type of screwdriver. This one uses bits, but we'll get to that in a bit, pun intended. So we have that. Then we have this, which is called striking screwdrivers. Now it's obvious that this screwdriver does not have my looks, so why is it called striking? Well, that is because it is used to deal with stuck stubborn bolts and nuts and so on. The basic idea is, by design, it has a steel core all the way through, and the handle is just sort of wrapped around it. Unlike these screwdrivers where this one is see-through, you can see that the handle is inserted somewhere halfway through, and it has this protrusion to prevent it from spinning when you're applying torque, but it doesn't go all the way, and if you hit this with a hammer you will break the handle and cause some damage, maybe even injury. These screwdrivers are designed to be hit with a hammer. Now, why would you want to do that? Well, if you have a stuck screw that's rusted or something, it helps when you spray some penetrating oil and place this on the screw to make sure that it fits nicely, and hit it once or twice, and that sometimes gets the bolt unstuck. So these are not to be abused or hit with the greatest possible force, especially depending on their size, but they are used for striking and designed to sustain that. Sometimes they have just a cap on top like this one. Sometimes they have this bulky end, and here you can put a wrench to add some torque, or use this part with the wrench to add some torque. That's also some of the variants that you see in various screwdrivers, not just the striking ones. So we have that kind of screwdriver. Some have a hole for a ratchet to use. So there are different designs when it comes to that. So we have those kind of screwdrivers, and this is not a chisel. Do not use it as a chisel. There are special tools used for cutting by hitting them and carving stuff, but this should not be abused. You should only use it on screws. That's what it's designed and intended for. This is a special kind of screwdriver is called impact screwdriver. It's like a variant of the striking one. So first you want to hit the bolt to get it to loosen by striking it with the screwdriver, and then I usually like to leave this aside and use the impact screwdriver. And the impact screwdriver lets you hit it with the hammer, and at the same time when the hammer is hitting it, applying downward force to prevent the screwdriver's tip from coming out of the bolt or screw. At that time this is also turned to unscrew. Here I will try to demonstrate. So when I'm pressing it now, but you can see it turns to unscrew. So that's pretty effective and good. This particular model has a lock, and so you can use it both as a striking first to tire and wire down the stuck bolt, and then use this option to try and unscrew it, hopefully. So that is another type of screwdriver. And then we have these different kinds of bit holding screwdrivers. Some have shorter attachment, shorter blade, some have longer blade. So we also have different kinds of bits. Let me see if I forgot something to mention. Yes, I did. The ratcheting screwdrivers and other screwdrivers that have some sort of mechanism. Let me just show you in a second. This is a ratchet. I can lock it to screw something in, or put it the other way around to unscrew stuff. So that's what it does. And there are some screwdrivers with a switch, usually somewhere here or someplace else, that allow you to work them as you would work this. So you just turn handle and you can work. By not taking it out or removing your hand, you just keep going. So ratcheting screwdrivers. And by the way, this is the one that has the attachment for the extra torque like this, and such for sockets attachment. So this is a special kind. We will not be discussing this any further now. And this one is a bit of a special mechanical. It's not a ratcheting, but it's one that allows you to spin this by just, let me show you. If you can see, I can spin this by just 1/4 of a turn, and this turns 4 times more, so 1 whole turn. So it has its pros and cons. I already made a video. I don't like this particularly, but there are different kinds of ratcheting and other mechanics in screwdrivers. That's another type. And I think this concludes this topic. Now let me see. Yes, handle, shape, size and material. Where do I begin? Let's start with the handle shape. So here I will take these similarly sized screwdrivers and try to demonstrate. This is a round handle, and some people prefer that it has this narrower part. So if you want to use more speed at less torque, or get a better feedback because you're not using high lever to not over tighten something, you can use that part, and you have this for more torque. These are practically the same. Then this one has a square profile. So that's another thing. This is very good screwdriver, Bernstein. It's for fine electronics and things like that. So this may be better for fine tuning, so that you can see how much you've turned it. And similar, it holds good, fits in the hand nicely, and it's nice for precise low torque work. This is a sort of a hexagonal, similar to this one. So you have that shape. Then this one is basically a triangle. It's destroyed, but it basically is a triangle profile in this handle. So that's another one. Then we have some that are with a bit more texture or smoother. Also the material is different. This one is like some rubberized plastic. This is almost completely rubber. This is completely hard plastic. Yes, we also have a smoother variant of a basic square profile. So different people and different jobs and tasks have different preferences. So that's very much a kind of what you choose, but there are options. Of course, this one has a special design. It's like a T screwdriver, and it has the advantage that you can hold it here nearby to apply less torque and get better feedback, or here so that you can get good feedback for higher tightening torques and use it to unscrew stuck stuff and things like that. And you can use this to spin it. It works like a sort not a pendulum, but this mass rotating lets it spin very nicely, very quickly, so that you can work very fast with this. I'm not sure how to call that in English, very sorry about that. Now, that's about material size and shapes. Yes, just size does matter, of course. So here, I will use this example. Here we have Phillips 2 screwdriver and Phillips 1. So here the material and the shape of the handle is the same, but their sizes differ. And why is that important? For the torques that I am likely to be using with Phillips 2 screws, this larger handle lets me apply more torque if I need to, but it has this narrower shaft for spinning it faster when I need to work. However, with Phillips 1 screws, even the narrower part is narrower than this one here. So this handle is more suitable, and it's easier for me to work with this smaller handle when I'm working with smaller screws like the Phillips one. So even the blade thickness differs, as you can see here, and that's also important because sometimes you have a screw that is very deep in a small hole that is just the diameter of the screw's head, so you cannot fit a wider screwdriver. And for example, I just want to use this before I make a separate review. This is also Phillips one, this is also Phillips one, but this bit, it was made to be a bit thicker, so it cannot fit some places where I tried to use it, and I had to reach for this screwdriver. It's a very small difference, but I probably could measure it with a caliper. It's enough to create problems. So there are different designs, and for me it's best when the blade thickness is suitable for the tip type and size. It's bad when they are mismatched. You get a bit more power and strength, but it's usually moot because the tip is the weakest point, and the screw gets when the screwdriver gets cams out. So that's not something that I quite enjoy. I prefer to have it as slim as possible, as needed. And another thing, I think I've covered it now. So you can have a too big. When it's too big and bulky, you work too slowly for smaller torques. So it's best when it suits your required the bolt size and the required torque that you are likely to be using. That's why when you buy separate screwdrivers, they usually have a handle that matches the size of the tip. So I hope I've explained that clearly. And now let's go on about bit driver sizes. Here I already mentioned some of these bit holding screwdrivers. There are 4 different bit sizes, and I've made an article about that, and I'll make it pop up in your top right hand corner if I don't forget, where I've explained this in great detail. But generally you have most likely come across this one that is 1/4 of an inch size, and that is the most commonly seen and the most commonly used bit, and that's what it looks like. But this is a very small one. It's used in these precision screwdrivers for fine electronics and things like that. This is the only one that has nominal size in millimeters, and it is 4 millimeters. This one, I usually use this one with my socket wrench and hold it in this. This is a larger size, and some larger impact screwdrivers for cars and motorcycles use these kind of bits. This is 5/16 of an inch size, and here, as you can see, this is a Phillips one, this is also Phillips one, but this one has a lot narrower shaft, so you can get into some difficult to reach spots, even though this one is too short for my taste, and I'm not very pleased with this one, but never mind the basics. You can see with 5/16 of an inch I cannot find Phillips one size. I don't have it. It makes no sense to make it, so it's used with smaller bit sizes. So let's sort them by size. There is another standard that I don't have in my garage, and I practically don't use it, and that is 3/8 of an inch size, and I cannot show it to you because I don't have it, but it's even larger than this 5/16. So now that we've covered that, let us move on. Bit drivers versus screwdrivers. We have the showdown. It's on. Bit drivers have a very good advantage, and I quite like them. I will show you first why I like them, and then I will show about and talk about their downsides. For example, if I need to do some field work and I want to do some furniture, in my country the furniture and the wood screws are usually done with the POZIDRIV standard. So I will be carrying POZIDRIV one screwdriver for small screws and for cabinets and stuff, and POZIDRIV 2 for larger screws. I will also be carrying POZIDRIV 3 and some other, but this is just the basic example. And if I want to do with some kitchen appliances, mount, open them, fix the wires and things, I will also be carrying Phillips 1 and Phillips 2. So there I have 4 screwdrivers, and this is the amount of space they will require in the list. However, I can just use 1 bit driver and carry 4 bits. And this is the amount of space I need for that. You can see the comparison. The more screwdrivers and the more tip sizes and types I need, the greater the difference. I can also carry these shorter bits. These bits are very long. I can carry these shorter bits in a box like this, and here I have a great deal of choice about bits for bit sizes. But there's also something like this for the longer bits. So anyway, it takes a lot less space than stacking screwdrivers. But that is also a downside, because the downside is, for one, I am limited to one size of the handle. Okay, in these two combined fit a lot of stuff and get a lot of stuff done. Sometimes if this is near some wall or something, so I cannot turn this, I might even look for a third size, like something in between two. But with 3 screwdrivers I can cover all the handle sizes, practically all the handle sizes I need. And after that, if I carry 20 different bits, it's just small amount of space, so it's still more compact compared to carrying separate screwdrivers. But it is a downside that you have to worry about it and carry several. And if I have more people working and have only 1 or only 2, I cannot hand them to work alongside. It takes it can be a complication, so I will have to carry even more, while with this one you have as many screwdrivers as the tip sizes you have and need, and so it adds a bit more flexibility, but it's more cumbersome. So pros and cons. Another problem that I noticed with the screwdrivers will be explained later on. These have more downsides, even though I love them. But here I will first show you my selection of bit holding screwdrivers, what I use generally, and explain which ones I like and why. So let us start with basic ones, the short ones, the stubby screwdrivers. These are very short. They have the magnetic handle, that magnetic system that holds this with just a handle. And the downside of that system is that good quality bits can sort of bite into a screw, and when you remove the screwdriver, if this stays stuck in a screw, it's okay, but often it then just drops out and you have to look for it. And if you're working somewhere on the ground, grass or something, it can be quite frustrating. You can also use longer bits with these, and the longer bits have an advantage that, let me show you with this one, it's more clear. If you have a longer bit compared to using a short bit, this part is a lot less bulky than this section, and sometimes when you need to go somewhere deeper or tight space, this can be a problem. I ground this down a bit just to give me some more clearance, but this is for me preferable. Of course, when you have a longer bit, there's more wiggle at the tip, which sometimes can be a problem. It's a longer lever and it's basic geometry, trigonometry, so they have their downside. So I have these small short ones, I have this larger one, I have these that accept the bits very near the handle and are more suitable to using the longer bits, because this one, if I put a long bit, it's very awful, or very long, it's very problematic. And another thing is that there are some that lock these in place. So this one has a locking mechanism. This cannot fall out, and that's brilliant. This is made by company Wera, and it's called Rapidator or something. Their marketing team is very inventive. but it does the job, it works well. This one has a spring that keeps the bits in place, so you can pull them out, but it takes a lot more force compared to the magnet, so it's still good. So I have this impact one that can be locked and used as a striking screwdriver. So it's a smaller size, 1/4 bits. It's not those bulky impact drivers that I usually see and use. So this one is very suitable for bicycles and finer work, but when you get stubborn bolts. So we have those. Did I forget any? Yes, we have this one. I made a video about this one. Maybe I'll make it pop up in your top right hand corner. I think this sucks, and I almost never reach for this one. So I think I've covered most of the stuff, and I will just briefly discuss another thing about bits, which I almost forgot. These, it's explained in my article, but they have different attachment mechanism. This one has like a groove, and this one has like these small slots. Sometimes they are completely smooth, but usually they have something like this, and that's used to lock them in place. And these ones that have small slots are generally easier to hold in place without moving a fraction of a millimeter, while these are a bit more difficult to keep in place because this is smooth and you need a bolt to press hard on it and some preload, and it's not something that you would generally expect from most bit holders. So this is very good based on my experience compared to, we'll get to that a bit later, but those are differences. This design is called power bit, but not all the bits for power tools that use a lot of hitting force to create torque, not all the bits for power tools, not all the bits that have this groove are suitable for power tools. This one is not. So you have to always make sure that you check the manufacturer specification and not just rely on this shape to confirm that this is a power bit, that it's suitable for power tools. Another thing are bits that I got and with this one and to use it with it. These are designed to be used for hitting, striking, and very high, relatively high torques that this screwdriver produces when I'm using it as an impact screwdriver. So these are a lot stronger than this one, and here you can see this is POZIDRIV 1 and this is also POZIDRIV 1, but see the size of the blade of its shaft. It's very thick. It's designed to be robust and to take huge torques, but of course with this one you would have problems getting into some tight spots, so there's always a downside. So that's about it. Let me see now the measurement methods. Yes, I know that I'm pleased with some of these bit holding screwdrivers more than with the others, and I thought, okay, something that I can feel in my hand, this is sloppy. That's very subjective, but I wanted to find a way to measure it so that I can compare it. So when I'm looking at getting some new screwdriver, if I can find the data of the sloppiness in degrees and millimeters, I can compare it and see what works for me, what are the limits. And I am also showing it here so that you have something that's measurable and comparable and repeatable, so that you can see for yourself. Maybe something that I consider to be too sloppy is okay for you, and that's okay, and you should know by something that's measurable, not by just me saying this is crap or this is brilliant. So what I did, let me find here. I got this is a cardboard, and I also got this. I punched in, made a hole and punched this in this screwdriver bit so that I can put this at an end of a bit holding screwdriver and then measure in degrees how much slack there is in terms of rotational before it locks out, when all the slack is taken out. So I made this be a bit protruding, and I used the cardboard to put it in place and measure the amount of sloppiness. And I also made a system with a grip to hold this locked in a vise. I will show it now just for giggles. Give me a second. This is what I used to hold this in place, screw them in and hold this in a vise so it's fixed, and I'm just measuring the slop of the mechanism, not the handle, because if I held it in my hand it was not precise enough. I will also explain why that sloppiness is a bad thing for some tasks and why it's besides being annoying. So I measured that, and I also measured using some square bits that are flat at the end how much back and forth movement there is. I measured that using a caliper and I put it all in a chart. Before I show the chart results, I will just briefly discuss why I hate this sloppiness. One example that I often use is when I need to tune a rear derailleur, for example, and set its limit screws. So those screws are relatively small and they don't take much torque. You tune them, you turn them a bit in or a bit out, and they use 1 Newton meter of torque, if not less than that. So you don't really feel your screwdriver getting into it, you just see it move. And for me, when there is a slack in the screwdriver's head, say I want to tighten it by quarter of a turn. To tighten that screw here, if I start turning the head of the screw, the handle of the screwdriver, I'm almost halfway to quarter turn, and this is just taking out the slack. But here I'm holding this firmly in my hand, but when there's very little torque in the screw, then I don't have that feedback. When have I taken out all the slack? When have I started to turn the screw? So I have to look with my eyes and use more concentration and care. So it's usually with Phillips 1 or Phillips 2, so it's not something huge. So sometimes you can miss it and it gets tiring and frustrating, and I don't like my tools playing tricks on me. So having too much slack is a problem for me and I don't like it, besides it feeling a bit flimsy. But when there's a very little slack, like here, it's no issue whatsoever. For the movement back and forth, up and down, let me show you here. This is an extreme example. This one is held in some electric screwdrivers. That's how I use it. This one has a huge amount of back and forth play, in over 2 millimeters. So that is sometimes a problem when you need to approach something, then move out. But generally, if you are able, if the work you're working on is such that you can press it in and remove the slack, it's not much of a problem. Of course, it's better when there is the less play there is, the better. So this one has very little play. And now let me show you the results of the measurements that I did. Here is the table, and this is the amount of rotational slack that I measured with this gadget, and this is the amount of back and forth movement with power bits, so this kind of attachment, and this third column is for these kinds of attachments, so the ones with small slots. So we have the Chinese. By that I mean all these that use magnetic tip. Some, most I have are no names, so I just named them Chinese, and they are very similar. The differences between them are within a margin of error, though this one is very bashed up now and I've done all sorts of bad things to it, so it's worse. But with the new one I tested, they are all quite consistent. So we have the Chinese, and they have about 6 degrees of turning slack, and I had nothing to measure the back and forth because it holds with a magnet. I either break the magnet or not, so this is not an issue with those. Then this is the one I mean by Metabo. This one is held in a drill, so there's no added slack by this interface, just measured this one, and it has very little rotational slack, 4.4, but huge slack in back and forth for the power bits, but also huge, over 1 millimeter for the non-power bits. Then this is one of my favorite, the T-handle 416R model by Wera, however the Germans pronounce it. 5.4 degrees of slack, very good subjective feeling, almost no slack, and also 0.8 millimeters with power bits and 0.3 millimeters only with these normal bits. So very firm, and in my hand this feels like it's almost like a normal screwdriver, not a bit holding. So this is acceptable. 816R by Wera, this is the one, the slick sidekick of our bubblegum chewing butt kicking hero. So this one has 6.4 degrees of rotational movement slack. 0.9 millimeters with power bits and 0.8 millimeters with the normal bits. So very slight differences compared to the T-handle, and for me this also feels subjectively like they're the same, like they're both just as good. However, when I pass the 7 millimeter limit, or this one is past the 8 millimeter limit, that is this one, the impact, when locked, I measured it when locked to be used as a striking screwdriver, not as an impact. So Wera 921 model. This one has noticeable rotational play, so for me when you pass 8 millimeters it feels a bit sloppy in my hand and I don't really like it. It's not very comfortable, it doesn't feel confidence inspiring, but because it has a spring sort of system, it has very little back and forth movement. 0.3 with power bits, 0.1 bit with millimeters with normal bits, and the force is quite high required to take it out, but I prefer this kind of locking because you cannot pull it out until you pull this. So it's a safer locking, even though it has a bit more play. It's not a lot of play, it doesn't bother me, and it feels more positive to lock it in, so I prefer this. We'll see how long it lasts. It's plastic, maybe it will be destroyed in a year, I hope not. And finally the crappy screwdriver that I don't like at all. Sorry for bashing you, it's nothing personal, you're just a strange looking guy with a foreign accent, so it's you must be the psycho villain in this this video. And this is Turbo 826T by Wera. It has 34 degrees, this is not a missing decimal point, 34 degrees of sloppiness in terms of rotation, but in terms of back and forth it's quite good, on par with the 816R model, so it uses the same attachment system and they both have the same amount of, the same way they hold bits, so all the sloppiness is within this mechanism inside probably. That's where it generates, so because it has that super smart mechanism that works like crap in practice. So those are the metrics. I hope you find it useful and for comparing and figuring things out. So I hope I haven't missed anything important. If you have any questions or comments or corrections especially, please use the comment section below. Thank you very much if you sat through this whole video. I'm sure it wasn't short, but I hope it was informational, educational, and I hope it will be helpful. I wanted to make this sort of a encompassing video related to screwdrivers before I make any more particular model reviews or presentations or anything. And when you see me working in some videos, sometimes I even fix some bikes, then you will know what I'm using when it comes to screwdrivers at least. So of course don't forget to like, share, subscribe, support me on Patreon, that also helps. Thank you very much for my Patreon supporters, it means a lot. And again, I'll thank you very much for watching. I will see you in some other video. Hope you've enjoyed this, and cheers.